All right. A compound inequality is formed by two inequalities with the word and or the word or. So these are your two types of compound inequalities. Ones that use the word and ones that use the word or. The graph of a compound inequality with the word and is the intersection of the graphs of the inequalities. So if you're given an inequality with the word and, they're going to say something like x is greater than or equal to 2 and x is less than 5. So if you were to graph x is greater than or equal to 2, you'd use a closed circle and you'd shade to the right, greater than 2. If I said graph x is less than 5, you'd use an open circle around 5 and you'd shade to the left like they did there in the middle. But a compound inequality, that wouldn't make sense to shade the whole number line. It's only the intersection of those. So instead of closed circle arrow to the right and open circle arrow to the left, I've got closed circle shaded all the way to an open circle where they overlap. Okay, that's an intersection. It's like saying to ride this ride, you have to be taller than 4 feet, but less than 7 feet, or you'll fall out. Does that make sense? If they just said taller than 4 feet, the 7-footer's not fitting in there. They also have to say less than 7 feet. So it's like a range. For this compound inequality, is the number 2 a solution to the inequality? Yes. Is the number 5 a solution to the inequality? No, open circle. Yeah, there was a no equal bar right there, right? That's an and intersection. So there's actually 2 ways you could write it. You could say 2 is less than or equal to x, or I like how they said it originally, x is greater than or equal to 2. And then use the word and, x is less than 5. Or most people actually refer to it like this. And they don't use the word and, but it's implied. X is between 2 and 5. 2 included, 5 not included. That's how you see and intersection inequalities. Okay, so instead of shading the whole number line, x is larger than 3, x is less than 7, instead of shading the whole thing in, you only shade where they overlap in. And that's kind of what they were showing you here. The overlap here, but these dotted lines are showing you right here. Where's the overlap? It's right here. That's the only thing I'm shading. Yeah, Shane? No, x be in the middle. Okay, which makes sense to me too, because x represents what I'm shading, and I'm only shading between those two numbers. Now we have and compound inequalities, and we have or compound inequalities. The graph of a compound inequality with the word or is called the union, which is a misleading word because when I think of union, I think of 2 things coming together, and that's actually what the intersection is. The union means 2 things are splitting up. So I guess you could think of the Union and the Confederacy, right? They're going in different directions. The graphs show numbers that are solutions of either inequality. So if I said y is less than or equal to -2, you'd close circle shade to the left. If I said y is greater than 1, you'd open circle shade to the right. And instead of there being intersection between them, there's no intersection at all. You're actually shading in 2 different directions. So and inequalities are going to look like this. Whereas or inequalities are going to look like this. And that's really it. Can you remember that? Maybe. They're easy to do. Okay, we'll do some problems together. And again, I put this reminder in there just to remind you that when the word and is being used, typically, they'll just write it like that. They won't use the word and at all. It's easier to see the x's between. It's the intersection of those 2 numbers. You shade everything greater than -8 with an open circle, and everything's less than 4 with a closed circle. You shade in between those 2 numbers. So x is between them. So first couple questions we're going to do, we're going to write these compound inequalities. A number x is greater than -8 and less than or equal to 4. So we'll start with the first one. X is greater than -8. X greater -8. And X is, let's say, less than or equal to. X is less than or equal to 4. It's pretty easy. Connor, could you shut the door for me, please? Thank you. But as I mentioned, most people won't write that. That's too much to write. Instead, we'll make it look like this. I guess it was just 4, not -4. Now, this is exactly the same. Both these are exactly the same. Signs pointing in the same direction, everything. But here we had to flip the sign around. And the reason we had to flip the sign around is because we switched X and actually wrote it in the middle. And so for this inequality, if we switch X to that side and switch -8 back over, we still have to show that the sign's opening up towards the X. So here it's opening up towards the X. Okay, so now we're writing it so that we're saying -8 is smaller than X and X is smaller than 4. So it's in the middle. It's between those values. You could write either one of those. Example B. A number y is at most 0 or at least 2. How do I show that y is at most 0? What would I use for that? Xander?
Y is less than or equal to 0.
Good. That phrase at most means that 0 is the maximum and that it can't be any larger than that. So it's got to be less than or equal to 0. What about the phrase at least? What if I said y is at least 2? Brady?
Greater than or equal to.
Good. Y is greater than or equal to 2. Now, in the notes that we did on Tuesday, the homework you just turned in, if I go to the notes from Tuesday real quick, at the very bottom of those, you remember doing this in class? Shapes. At the top of that, there was that chart. Remember I said this chart might come in handy. You'll see phrases like at most, no more than, at least, no less than, just to get you familiar with what symbol you're supposed to be using. If you don't want to refer to this chart, you don't have to, but it is a good thing to remember that when it says at least or no less than, it's referring to that being a minimum. And so that's why we use the greater than or equal to symbol. And when it says at most or no more than, that's referring to a maximum. And so we're going to use the less than or equal to symbol because we can't go any higher than that. It says at most. Now, with or inequalities, there is no fancy way of writing it like we did for that one there. We literally just have to write the word or between them. That's it. So it's essentially 2 inequalities. You can't combine them because we're not shading the space between them. They're going that direction and one's going that direction. So basically we're saying every number imaginable works. Every number you can think of will work except those numbers between 0 and 2. For whatever reason, those numbers don't work. Well, 0 does, because that one's a closed circle. So 0 does work, but anything higher than 0, but anything between 0 and 2. Actually, they're both closed circles. So 0 and 2 both work. I didn't even look at the last one. 0 and 2 both work. Anything between them does not work. Example C. A number D is more than 0 and less than 10. D is more than 0. What do I write for that? Jace, D is more than 0.
D greater than 0.
Okay. And what about D is less than 10? What would I write for that? This will make you think. D is less than 10. What do I write for that, Seth? Great idea. D is less than 10. Now, what would I write if I wanted to write the combined version? Lizzie?
D is 10 is greater than D.
Start with 0. Start with your small number. 0 is less than D, which is
greater or
less than 10. There you go. Yeah, that one, it's kind of, you'll get the hang of writing that. You'll get the hang of writing that. You're really just flipping this one around and leaving this one as it was. Make sure you start with your smaller number first. Even if it's negative, start with your more negative number first. I would accept the first notation. I would accept that. Okay, just so you know. Example D, a number is fewer than -6 or no less than -3. Christian, how do I write that a number A, so I guess I'm using A, is fewer than -6? Good. Now, because this is an or inequality, I don't have any fancy way of writing it. I just have to literally write them separately with the word or between them. Do not forget to write the word or. That's a very silly way to lose a point on your test next Tuesday by not writing the word or. You don't have to write the word and if you write it like this. If not, make sure you have the word and. That's another important word that you would need, unless, of course, you're taking a shortcut and writing it like that, writing the combined version. But you do need the or. Or has to be there. There's no fancy way of writing it without the or. The other one says that A is no less than -3. How do I show that A is no less than -3? Same three people. I just called on Christian, otherwise I would have. I appreciate you volunteering. Owen. That's right. If A is no less than, that means -6 is the minimum, so it's going to be greater or equal to -6. And that's it. There's no, again, no fancy way of writing that one. Now, instead of writing them, let's graph them. Well, actually, no, we're still writing them. Never mind. I got ahead of myself. But instead of writing them from words, we're going to write them from graphs. Use the number lines to write a compound inequality that describes each interval. So I'm actually, before we do these, I'm going to go down to E. We're going to answer this one first. Do these 4 inequalities represent an and intersection inequality or an or union inequality? Jimmy? And, good. Circle the word and. Because it's shading between. Or's shade like this. So and is like this. I'm shading between them. Intersection. Okay, so these are all ands. So keep that in mind. Because they're all ands, I don't actually have to write the word and as long as I write the smushed together version. These are called half open intervals. These are called closed intervals. And this is an open interval. Can you figure out why they use those terms, Xander?
Because in the closed interval, both circles are closed.
Yes.
And in the half open interval, one is closed and one is open. And the open, they're both open.
Yeah. So if both circles are open, it's an open interval. Good. Both circles are closed, it's a closed interval. And if one is open, one's closed, and I guess it doesn't matter which one, it's called half opened. Okay. So let's use the letter X for this one. Brady, what would I write?
X is,
Write the smushed together one. Challenge it. Okay.
less than or X, less than.
Good job. -6 is less than X. Or flip around and say X is greater than or equal to -6. You could flip around and say the same thing. Think of it that way. Up until it gets through. So you got to put the 3 here. You got to put the -6 there. Between them's the X, and you got to know which sign to use. And the signs should be opening like this all the time. As long as you write the smallest number here and the largest number there, these signs should be opening like this each time. So this should be less than or equal to, because this is half open. Who wants to try the next one? Yes, Alex. 5. So close. But what about the circle around the 4, Alex? Or equal to. There we go. So we got to put the equal to right there. So it's new, but it's like, I don't know, newish maybe? Like that's not new, like knowing open or closed circles, but we've never seen an inequality combined like this before. That's the new part. Who wants to give this one a try? Go ahead, Sky. Okay, try again. These are both closed circles. Both of them are also equal to. There we go. Lizzie, you gonna try the next one?
-3 is less than x, less than 6.
Good job. Those are all and inequalities. So on an and inequality, they're shading towards each other. You're only shading the intersection. So when it says x is greater than -3 here, I don't shade all of the numbers greater than -3 because I have to stop because it says also x is less than 6. So it's really just the intersection of those two. Those are and inequalities. That makes these what? Xander? Or inequalities. Or inequalities. Remember, or inequalities look like this. They're shading in opposite directions. That's really one of the main things to remember about or inequalities, opposite directions. This or that. Shane, you want to give this one a try? All right, let's do example A. That's exactly right. You have to write the word or. There's no fancy way of writing this one. You have to use the word or, and you're just writing them down as if they were two different inequalities, because they really are. So when we use the word or, we're saying everything works except for these numbers in the middle, the exact opposite of what we said last time. Okay, who wants to try the next one? Go ahead, give it a shot. Dawson.
X is less than -5 or x is greater than or equal to 4.
Nice job. Next one. Carter.
-4 is less than or equal to.
Start with that. Start with x.
X is less than or equal to
-4.
-4. Or 5 is less than or equal to x.
Sure. I'm going to write like this though. Instead of saying 5 is less than or equal to x, I'm going to say x is greater than or equal to 5. All right. Same thing. I think it just makes more sense with the way we've been going. Yeah, make sure we're not smushing these together though. Make sure we're writing the word or and separating them both. I would count what you said correct, except I think for the first one, you said -4 is less than or equal to x. Actually, if you wrote it that way, Carter, you'd have to say -4 is greater than or equal to x because x is small.
No, I just said it.
Did you? Okay. Last one, Carson, give it a shot.
Less than -3 or x is 6.
All right. Questions? Which of the two inequalities, ands or ors, are more exclusive? Meaning there's less possible values. Jimmy? Ands. Because for and inequalities, we're saying nothing works except for the intersection of those two. So the only numbers that work here are -6, -5, -4, -3, -2, -1, 0, 1, 2, not 3. If I am looking at or inequalities, they're more inclusive. Instead of the only thing that works is this, it's everything works except for this. They're shading to -infinity and +infinity, whereas the and inequalities. So I told you, if I can go back to the homework, I told you we'd be using these buttons here. We only use these buttons for and inequalities. The or inequalities, we're still going to be using these. Now, if you've been graphing, and I know it's frustrating when you're graphing and you click the wrong one, you notice you click the wrong one, you know you have to hit the trash can and re-click it, right? If you click off and click a different one, it puts it on there as well. You're like, why is it even doing that? That's because for or inequalities, you can have two different inequalities going different directions. Okay, so if you make a mistake, click the trash can and then you have to tap on what your mistake was, it will delete it for you. All right, now let's get to solving. To solve a compound inequality, solve both inequalities separately. Okay, that's easy enough. If it's an or, hold on. Okay, I'm getting ahead of myself. To solve a compound inequality, solve both inequalities separately. This is assuming that it's, I guess it's really assuming that it's an OR inequality. So if it's an OR inequality, it's going to say something like 4x is greater than 8, or negative 2x is less than or equal to negative 12. And you'd solve them both separately, and you'd graph them like this, here, that way. For and inequalities, perform the operations on not both sides, but every side. What could he mean by that? Well, I'm glad you asked. Oh no. Disappointment. We started with an OR inequality. So this one's the lame one. So I'm going to solve these both separately. These are both two-step inequalities. The first thing I would do on the left side here on this inequality is get rid of the -5 by doing what? Brady? Okay, when you add 5 to both sides, what's -8 plus 5? Okay, divide by 3, Brady. Okay. Or do the other one. It's like literally, it's like it's 2 problems in one. Okay, so do the other one. Garrett, what do I do first? Okay, what's 5 plus 1? Divide by 2. Okay. So I've got an open circle around -1. A is small, so I'm shading to the left. Open circle around 3. Oops, why did I switch that? A is big. I was going to say A is big, but then my variable, my inequality symbol was not facing the variable. So A is bigger, so I'm going to shade to the right. Now, it's a giveaway. When it uses the word or, you know it's going to be looking like this and that. You know it's going to shade in both opposite directions. It's just a matter of where do I put my circles. This inequality, am I going too fast? This next inequality is what type of inequality? Xander? An and inequality. So it's going to look like this with open circles on both of them because there's no equal bars. Just a matter of where do I put my circles. Now, the reason I said perform the operations on every side is because if it's written like this, I can't say both sides. There's actually 3 sides. There's a left side, a middle side, and a right side. So what I do to one side, I do to all of the sides, is maybe a way I should say this. In order to get B by itself, I have to get rid of the -2. How do I do that? Jace?
You gotta add 2.
Yep. So I'm going to add 2 to that side, add 2 to this side, and add 2 to that side. So now I have -2 is less than B is less than 5. It's kind of unique, but also not super difficult. So I'm going to put an open circle around -2. I'm going to put an open circle around 5. B is between them, so I'm shading them like this. So if I was graphing this on Big Ideas, I would click this button, and then I'd click -2 and then 5, and it should graph everything between. Here's another and inequality. It's a 2-step and inequality. Julia, what would the first of my 2 steps be?
Subtract 1.
Good. Julia, what's -3 minus 1?
-4.
And what's 2 minus 1? Okay. Did I lose anybody on that step? Add, or sorry, subtract 1 from both sides. Okay. Chloe, what's my second of these 2 steps? Okay, now remember back what we've been doing. Do you think I'm going to have to flip the sign here when I'm dividing by a negative?
Yeah.
Absolutely, I am. Absolutely, I am. That rule still applies. I'm going to flip both sides. So when we divide by -2, Chloe, what's -4 divided by -2? 2. Flip the sign. C. Flip the sign again. And then 1 divided by -2 is -1/2. Now, me flipping the signs does not mean that it's not going to look like this anymore. Whoops. Actually, it's backwards now because we flip the signs. It's going to look like this now. It's still going to be an intersection, It's just that when you divide by -2, remember we talked about this, you can see, remember I said if the smallest number is always written on the left, you'll use less than signs. Well, when we divide it by -2, now the smallest number is written on the right side, so we have to flip our signs around. Otherwise, it won't make any sense. So C is bigger than -1/2, but smaller than 2. So my closed circle is going to go around -1/2, and I don't have little half marks here, so just imagine it being right there. But an open circle around 2. Example D, another OR inequality. Maddox, walk me through this one. What are both my steps on example D for the left side inequality? Okay, 1 minus 1 is, okay, then do what? 0 divided by 2. Now, Maddox, do I need to flip the sign when I divide by 2? Good. Okay. So I know I'm going to put an open circle around 0, and since D is smaller, I'm going to shade to the left. And I can actually go ahead and do it because I'm not waiting to see what the other number is. They're not going towards each other, they're going away from each other on OR inequalities, or what they call union inequalities, which is kind of a weird word of saying, weird way of saying that. Deegan, describe the steps for doing this next one. What's the first thing I would do? Okay. What's -1 minus 3? Okay. What's the second thing I would do? Okay. What's -4 divided by -2? Anything else I need to do? Good job. Yep, flip that sign. Flip that sign. So now, because if you don't flip that sign, it's going to do this. And then you go like this, and you're like, okay, what am I doing? Well, you flip the sign because now D should be larger than 2. Because we know, again, that the secret is, OR inequalities look like this. So no matter what you do, it should end up looking like that, or you did it wrong. Last question. Electronical devices should operate effectively within a specified temperature range. You ever gotten that message on your phone?
Yeah, so many times.
Phone's too hot, like doesn't do anything. So, yeah, okay. Leave it in your car over on a hot summer day, it does that. Outside the temperature range, the device may fail. Write a compound inequality that represents the possible operating temperature range of this smartphone. Now, if I'm going to represent the range that this smartphone can operate in, and we're in degrees Celsius, remember 0 degrees Celsius we talked about is 32 degrees Fahrenheit. Would this be an and or an or inequality? Why do you say and? Yes, you want it to be between those ranges, not outside of those ranges. It's not if it's colder than freezing or hotter than 90, whatever, then it works. It's between these ranges. So you're right, we do want this to be an and inequality. If it says the operating temperature can be 0 to 35, does it include 0? Yeah, does it include 35? Yeah, so I'm using closed circles. I'm using equal bars, is what I meant to say. So let's use the letter T for temperature. 0, 35. The temperature has to be greater than or equal to 0. So I'm going to use a less than or equal to sign because I wrote my T on the other side. Still shows that T has to be bigger. And on this side, we're going to show that T has to be smaller or equal to 35. And I don't know why it underlines that. This is the way you spell electronical. I tried to mess around with it and it was giving me other ways of like electronically. That's not the word I want to write. Electronical devices.
I don't think it's electronical word.
Yeah. It's in your textbook.
I think what they wanted you to say was electronic. Yeah. That's what I would think.
We had to do it while I was recording. All right, we're done here. No. This isn't college.
Oh.